This time distance graph shows how far a person has walked from some starting point. We can tell the person is walking at a constant rate because the graph is a straight line. Every 2 seconds, the person walks 3 feet. This graph about a person driving is a little more complicated. At first, the car is driving away from starting point A. We see the distance from the starting point gets larger and larger. Then something happens. The graph gets flat. This flat part of the graph shows that the distance is not changing for a certain amount of time. Let's think about what might be happening when the graph is horizontal or flat. When the graph is flat, the car must have stopped. Then the graph goes back down. When the graph is going down, the distance from its starting point is getting smaller. Let's think about what might be happening then. When the graph goes down, the car is getting closer and closer to its starting point. We can use a motion sensor with a graphing calculator like these to make graphs showing the relationship between time and distance. For instance, a motion sensor can measure the distance to a moving person and create a graph showing how far away the person is at any given time. Here's the graph of a walker that is standing still. The graph shows the distance from the motion sensor stays the same. This time the walker moves towards the motion sensor at a constant rate. The graph slants down as the walker gets closer to the sensor. Notice how the graph starts at 3 meters because the walker started 3 meters away from the motion sensor. Here the walker moves away from the sensor at a constant rate. The graph slants up as the walker gets further away from the sensor. Notice how the graph starts at 0 because the walker started at the motion sensor. Notice here how the graph shows her distance to the sensor as she moves back and forth. In this one, she stays still at first. Her distance from the sensor stays the same, so the graph is horizontal. Then she moves towards the sensor so the distance gets smaller. Here she's trying to move in a way that copies the graph. With this graph, let's focus on the speed of the walker. At first the line slants up steeply. That means the distance from the sensor is getting bigger in a short amount of time. Then the line gets less steep, so it's taking longer for the walker to move away from the sensor. When the walker is moving faster, the line is steeper. In this lesson, we studied time and distance graphs to learn how starting position, speed, direction, and ending position influence these graphs.